Hi guys, welcome to Knowledge Base. Let us look at wave motion. This is the formula for the speed. The speed of any motion is giving us distance all over time. We are going to apply this formula in wave motion. In our previous video, we established the fact that there are some parameters used in wave motion. And today we want to use those parameters in forming equations used in wave motion. Starting with this basic formula that says speed equals distance over time, we are going to put in some of the parameters. And in the place of distance, we want to replace it with wavelength because wavelength is equally a distance. So we can say speed equals wavelength all over. Let's leave the bottom first. What is wavelength? Previously, we described wavelength as the distance covered by one cycle of a wave. In other words, wavelength, represented as lambda, is also distance. So in the place of s, distance, we replaced it with a specific distance called the wavelength. All we need to do is to put a time at the denominator that corresponds to the time of a wavelength. And what is the time to complete a wavelength? What is the time to complete one cycle? That time is simply the period of the wave, given as uppercase letter T. So this formula is now represented as this in wave motion, that speed is equal to wavelength divided by period, because wavelength is the distance covered by a complete cycle, while time is the corresponding time it takes, while T, uppercase letter T, is the corresponding time it takes to cover that distance. In other words, this formula is very important in wave motion. Lambda is the wavelength, uppercase letter T is the period. This formula should be taken note of. Another thing we need to take note of is frequency of the wave. Previously, we said that the frequency of a wave is given as the inverse of the period. Simply put, it is 1 over the period. If you look at this expression, we have the inverse of the period here. So if we replace the inverse of the period here with frequency, we have another formula that says speed equals f lambda. F for frequency, lambda for wavelength, because inverse of period has been replaced by frequency f. This is another important formula to take note of. With these two formula, we can be able to find the speed of a wave, the frequency of a wave, the wavelength of a wave, or even the period of a wave. Now that we know this, let's try a simple exercise. The frequency of a vibrating source is 450 Hz, and the velocity of the sound it produces in air is 330 meters per second. What is the wavelength of the wave? Let's sort the parameters out quickly. The frequency is given as 450 Hz. The velocity of the sound is given as 330 meters per second. We are told to calculate the wavelength, lambda. We have frequency, speed, and wavelength. Which of these two formulas accommodates these three parameters? Obviously, it's this, so let's use this. V equals f lambda. We are looking for lambda, the wavelength, so we divide both sides by frequency. That gives us lambda equals V all over f. Putting the values, we have 330 as the speed divided by 450, the frequency, and that gives us 0.73 meters. So this is the wavelength of this sound wave. Now you see it is very simple. Here is one for you to do. What is the frequency of the sound wave above? This sound wave we're talking about, what is its frequency? Please put your answer in the comment section and I will be there waiting for you. Thank you for watching this video and hope to see you in our next video.